Ni hao, Taiwan. My name is Mr. Mikołajczyk. I am in the United States, and I'm going to be teaching you guys in a couple of days about Newton's second law. So before we do that, as a quick pre-lesson on Newton's second law, the idea is in the U.S. what we've been doing is instead of having students read textbooks, we have them watch a short video and then answer some questions afterwards. So spend about 30 seconds talking about who I am and why I am talking to you. And I will also learn to slow down when I speak so I'm easier to understand. And then we will go through a pre-lesson together. Should be hopefully less than 10 minutes. And then where do you go from here? So the first thing is I'm a teacher in the United States. I teach all different levels of physics. A friend of mine who's also our Chinese teacher at the school knows about this program and talked to me about it. So I was interested in doing it and I'm excited to help out. I have been to Taiwan before. I was there my first time this past summer. I am in that photo there on the left, and in the middle is my wife. And of course, she made me put on the right side of it a picture of our dog, Pudding. So we'll start with the types of forces, which there are 5 that you're going to be using. The idea is in the lesson we're going to have together, you need to determine which forces are acting on an object so that way you can solve what is happening to the object. And so there are 5 forces that we need to be familiar with. We're not going to do a whole lot of math on the friction force or the spring force yet because this is just more about identifying what is acting on an object. So from there, kind of the questions you want to be able to answer after this is what forces are acting on someone when they sit in a chair or a block on a ramp, or if, say, a block is hung by 2 different ropes. So our first force we'll take a look at is gravity. And all you have to do is ask yourself, are you on Earth or the moon or any other planet? The answer will more often than not be yes. So, for example, if we talk about you sitting in your chair right now listening to this video, the answer is yes, the force of gravity is acting on you. If we talk about somebody who is going skydiving, they jumped out of an airplane, the answer is yes, there is gravity acting on them. If we talk about, say, a block sitting on the ground, yes, there is gravity. If we talk about a dog standing on the ground, there is gravity acting on the dog. And the thing is, gravity's direction is very easy to remember because it is always down. And last, the force of gravity is equal to mg, which is mass times the acceleration due to gravity. I'm not sure what exactly you're using in your class, but most people go with 9.8 meters per second squared. The second force is the normal force. The normal force is a force that exists because 2 solid objects are in physical contact with each other. It's what stops you from falling through the floor or walking through a wall. So all you have to do is ask yourself, for the normal force, are 2 solid objects touching each other? If the answer is yes, the normal force exists. If the answer is no, then it doesn't exist. So you stand on the ground. Are 2 solid objects touching each other? You are solid. The ground is solid. The answer is yes. You put a book on top of a ramp. The book is solid. The ramp is solid. Yes, there is the normal force. You go swimming in a pool. The water is liquid, therefore, no, there is no normal force. The direction is very easy to remember. The direction is always perpendicular to the surface, as shown here, it is perpendicular to the surface. So if you are standing on the ground, the normal force is up, force normal. The book on the ramp is at an angle that is perpendicular to the surface. Third is friction. There's a lot that goes into friction. It's a pretty complicated force to deal with. So for our purposes, we're going to keep it simple, at least for now. The question you just need to ask is an object sliding across the floor? So maybe it's a book that you pushed on the table and it is moving to the right. Yes, there will be friction between these two solid surfaces, and friction would be opposing it to the left. And the reason why friction exists is because the book and desk, although it may look smooth, are not actually smooth. And since there are imperfections and bumps all over the book and the desk, they get interlocked with one another and slow the book down. If we go to something, say, you are standing on the ground not doing anything, there's no friction. The reason why is you're not attempting to slide across the ground, so there's no need for it to exist. Tension is if there is a rope or chain or cord present. If the answer is yes, then there is tension. If the answer is no, then no tension. So perhaps you hang a block from the ceiling. There would be a tension force acting on the block. It will pull the block upwards. You are attempting to drag a box across the floor. There you are. And attached to the box is a rope. There would be a force of tension. Tension always acts along the rope. So in this particular case, with the block hanging from the ceiling, tension would be pointing upwards, directly along the rope. And in this scenario here, tension would be up at an angle, because as you can see in this very crude drawing, a person pulling the block at an angle. We can get even more advanced. Say you have two ropes that are hanging onto a block. You would have two tension forces, one towards the top left and one towards the top right. And our fourth and final one is the spring force. Just like the tension force, it's very easy to identify if it exists. Basically, are there springs? The answer is yes, there's springs, then yes, there's a spring force. There's a spring, you hang a block on top of it, the spring force exists. The spring force will always attempt to restore its initial position. So in this case, we hung a block on top of the spring stretched out. Therefore, the spring is pulling the block upwards, attempting to go back to its normal resting position. Springs can work the other way as well. If you have a spring compressed and you attach a block to it, so you are pushing it to the left, you would have the spring force retaliating and pushing to the right. Oops. And so what happens now, well, I'll come back to these three questions real quick, and we can answer them together. I almost forgot. The sixth and final thing is there an explicit push or pull in the problem? So that's very simple. You have a block here, and a person pushes the block, then yes, there would be an explicit push or pull. So my apologies, back to where do you go from here? And even before that, answering our three questions from before. So what happens when a person's sitting on a chair? So if you think about, here's a chair. Whoops, you're standing on it. Your drawing of your person sitting on the chair. Go force by force. Gravity was our first force. The answer is yes, there's gravity because this human is on Earth, so the force of gravity does exist. Normal force, two solid objects. The person is solid, the chair is solid, so yes, it does exist. This is the boundary of the surface. The force points up. Next up is friction. Does friction exist? Well, the person's not attempting to slide around on the chair, so no. Tension, spring, no ropes, no chains, no cords, no springs, so no to both of those. Any push or pull, we haven't been told, so No, this would be what we call the free body diagram. The free body diagram is how we set up equations, for Newton's second law, which is what we'll be focusing on in class. The second one, you have a block on a ramp. So you ask yourself, is there gravity? Yes, of course. The block is on Earth. Is there a normal force? The answer is yes. The ramp is solid, the block is solid. The normal force acts 90 degrees to this boundary between the two objects. Is there friction? Well, I actually didn't really tell you much detail on this. Let's assume that it's not moving. So if it's not moving, the only thing that would stop gravity from causing this to slide downwards would be friction. And that friction would be resisting gravity. Tension, spring, none of them exist. Any explicit forces, none of them exist either. Our last one, here's your block hanging. You have gravity, obviously, because, well, the block's on Earth, so gravity. Normal force. Although the rope is solid, and so is the block, we're not going to call it the normal force because the rope is unique. Tension forces, for example, can only pull. They're really just transferring the force from one position to another. If you take a rope and you attach it to a box and you drag the box, you are essentially doing the same thing as though you stood behind the box and pushed it. It's just transferring the force through the rope. Anyways, instead of using normal force, we'll use tension for the two ropes. No springs present. And then, the unique thing about this is, if normal force does not exist, there is no friction. Okay. So, where do you go from here? You're going to go through this worksheet, which does label out the notes on all of the forces I just talked about. There are more than these, but this is what our focus is on for now. And then attempt to draw the free body diagram in these 7 scenarios. What we'll be doing in class is taking a look at different scenarios such as this and attempting to solve for what's the acceleration, or what is the tension, or what is the normal force. Any of those different kind of questions we'll be looking to answer. Okay. Well, with that, if you do get stuck, do remember, go through your list of 5 forces, go through one at a time, answer the question that is asked. So for gravity, is it on Earth? Yes, so then put on gravity. And that's it. I will see you guys next week. Enjoy.